Now that you know why skip patterns are important and how to identify them, let's talk about what you should do to appropriately account for them. You will start by doing some basic conditional processing of your data and then follow up with some simple data checks to make sure everything turned out the way you expected. Next, I'll demonstrate managing data that includes skip patterns. For this demonstration, we're going to return to the Pap test example from the BRFSS. And we want to know the proportion of women in the United States that have had a Pap test in the past 5 years. However, we haven't yet learned to appropriately weight BRFSS data to represent the US population. So we will amend our study question a little bit. There. We know how to calculate the proportion of our participants that had a Pap test in the past 5 years. Now let's go through our checks. Here we see some red flags for a skip pattern, so we know that there's a chance that analyzing this variable without incorporating contextual information will give us a biased answer. Now, let's think about the context. We actually have two questions here that impose skip logic. Let's first think about sex. If the participant is male, they skip over the question about ever having a Pap test. So they will have missing values for had Pap 2. But if we think back to our study question, we don't care about males. It wouldn't make sense to include males in the analysis, so we are happy to leave them missing. Said another way, there is no contextual information hidden in this skip pattern that we need to account for. Now let's look at the next question. If the participant is female, they are asked about ever having a Pap test. If they have ever had a Pap test, then they are also asked when their last Pap test occurred. For the sake of argument, let's say that they had their last Pap test in the past year. Their data value then would look like this. No missing data, no skip pattern to account for. Now let's look at participant number 3. She is also female, but told us that she has never had a Pap test. And, as expected, she skips the question about the timing of her last Pap test. Therefore, she has a missing value for the variable last Pap 2. Let's stop for a moment and think about our question and our context. Is participant 3 a member of our stated target population and someone for whom we're interested in knowing more about? Well, she's a woman and she participated in the BRFSS, so yes. Is there any other contextual information in the data that we can use in our analysis? Well, if participant 3 has never had a Pap test, then it stands to reason that she has not had a Pap test in the past 5 years. So, even though she has a missing value for last Pap 2, we have contextual information we can use to help us understand the timing of her last Pap test. Now we could go about incorporating this contextual information in many different ways. I walk through one of those ways here. We'll begin with our original data. Here I'm just calling it DF for data frame. We're going to use DF as the basis for our new data frame, new_DF. Notice that new_DF has an additional variable, PAP5. We'll create this variable, which will store information about whether or not a participant had a Pap test in the past 5 years. And we'll create it using conditional processing. There are many ways you could go about doing so. Here I'm using dplyr's case_when function to do the conditional processing. Inside this mutate function, we're creating a new variable called PAP5. We are using the case_when function to tell R that the value of PAP5 will depend on, or be conditional on, the values of last PAP2 and had PAP2. In this first conditional statement, we are telling R that whenever last PAP2 is equal to 1, 2, 3, or 4, then we want the value of PAP5 to be 1. In other words, any participant with a value of 1, 2, 3, or 4 for last PAP2 was a woman who had a Pap test in the last 5 years. And in our fake data shown here, that would result in a value of 1 for participant 2, which is exactly what we want. In this second conditional statement, we are telling R that whenever the participant has a value of 5 for last PAP2, or a value of 2 for had PAP2, then we want the value of PAP5 to be 0. In other words, any participant with a value of 5 for last PAP2, or a value of 2 for had PAP2, was a woman who did not have a PAP test in the past 5 years. And in our fake data shown here, that would result in a value of 0 for participant 3, which is exactly what we want. In this final conditional statement, we are telling R that any other values of had PAP2 and last PAP2 we didn't explicitly address above should result in a missing value for PAP5. If you go look at all the remaining possible combinations of values for had PAP2 and last PAP2, you will see that they belong to participants who were men or were women that didn't provide us with enough information to determine if they had a PAP test in the past 5 years or not. And in our fake data shown here, that would result in a missing value for participant 1, which again is exactly what we want.